This problem is from GATE 2020 Mechanical Engineering of Set 1. The question is, for an ideal gas, the value of the Joule-Thomson coefficient is. So we are given four options. First is positive, second is negative, third is 0, or fourth is indeterminate. If you don't already know the answer, let me tell you, the answer is 0. Let's see why the Joule-Thomson coefficient for an ideal gas is 0. Now for an ideal gas, the intermolecular force, like suppose these are the gas molecules. Suppose these are the gas molecules. So the intermolecular forces between these molecules are 0. Okay, so force is 0. Intermolecular force is 0. So the collision between the molecules are perfectly elastic. And so the ideal gas do not show any cooling or heating effect because the intermolecular force is 0. Now let's understand the Joule-Thomson coefficient. Joule-Thomson coefficient. When the gas in steady state flow pass through the orifice or a valve, it normally experiences a change in temperature and is called Joule-Thomson effect. During this Joule-Thomson effect, the enthalpy of system remains constant, that is isenthalpic process, and the same can be represented as, so the Joule-Thomson coefficient is written as gamma. It can be represented by gamma, that is equal to dou T by dou P. That means partial derivative of temperature with respect to pressure, since the temperature is changing with respect to pressure at constant enthalpy. H remains constant. So this is the expression of Joule-Thomson coefficient. Now for cooling body or a heating body, let's see what is the value of Joule-Thomson coefficient. So for cooling body, gamma is greater than 0. That is, or you can say gamma is positive. For heating body, gamma is lesser than 0 or gamma is negative. Now if the value of gamma is 0, that means there is no change of temperature, no change. And this is what happens in the case of ideal gas. Since there is no force of interaction, there is no change in temperature because the collisions are perfectly elastic collisions. And since the collision is elastic, there is no loss of kinetic energy. So there is no change in temperature. And so we can say that the value of Joule-Thomson coefficient for an ideal gas is 0. Now to gain more knowledge on Joule-Thomson effect, you can follow the NPTEL course of Chemical Principles 2 by Dr. Arnav Mukherjee from the Department of Chemistry, ISAR, Pune. Hopefully I was able to clear your doubt. Have a great day. Thank you.